Hello, good morning, good afternoon, good evening. This is Samuel Anekan. Welcome you to Edison Online Academy. Wherever you are in the world, I hope you're having a good time. So in this video, I'll be taking through how you can actually draft a 10-inch flange, a flange, a 10-inch schedule 80 Weld-Neck Raised Faced Flange. In the next one video, after I'm going to draft the Weld-Neck flange in this video, in the next video, I will show you how to create the model, a 3D model, three-dimensional model of the flange. So don't end with this video. Proceed with us to the next one, where I will actually show you how to create the real-life model of the 2D drawing, which we will be looking at in this particular video. So before I go on, I would like you to subscribe to my channel, please. Subscribe to this channel, like the video, click the like button, click on the bell icon so that you will always be notified whenever I post any tutorial online. And also, please don't fail to invite others to this channel. Then drop your comments if you have any question. In case you want to connect with me directly, you can connect with me via +234-803829-5185. If you need one-on-one online lessons, I'm available. Just WhatsApp me on +234-803829-5185. So let me move over to the software. So like I said we'll be drafting a 10-inch Schedule 80 Weld-Neck Raised Faced Flange. So before you can actually draw the flange is actually a piping component. So I have an app where I'm getting the information from. I'm getting the information from Pipe Data app. So this is for a 10-inch. This is the schematic for a 10-inch Schedule 80 Weld-Neck Raised Flange. That is 900 pounds. This is 900 pounds. 900 pounds. So this is the information. This is the detail. So, but when actually you are drafting, you are just trying to create a picture in the office. You are just trying to draw so that the man on the field who is actually going to lay the flange, who is actually going to understands what you're trying to pass across. We don't have to draw to exact perfection. This is not creative art, this is not finance. So like this curve here, we're not going to add it. We're going to approximate. We assume that from here to here is straight. From here to here is straight. So we're actually going to divide this flange into 3 parts. Part 1, part 2, part 3. So the total length of the flange is actually 191. So first and foremost, I'm going to draw a line of 191. So I'm going to draw a line of 191. So this is a stop here. So now set your AutoCAD. Come to this gear icon over here at the bottom left hand corner. This is where my mouse is over. Come here, then choose 3D modeling. Make sure it's on 3D modeling. Then make sure your menu bar, show your menu bar, display your menu bar. Click on show menu bar. Mine is already showing. That is why I have hide menu bar here. Okay. So after you show menu bar, what next do you do? Come over here where you have Southwest. I have Southwest ISO. That is the view control, and change this to front. Change that to front. Okay. So now we're going to start in NS. So click on line and type 0, 0, 0, 0,0,0, 3 zeros, separated by commas, and press enter. Okay. So now, turn on your auto mode. This is your auto mode here. This right angle symbol. Turn it on and move towards the right. Move towards the right and type in 1000. Okay. So this is actually your line. So what's the next thing you're going to do? Come to this end of this line, and we are going to draw a vertical line of length 191. That is the length of the flange. Okay, so go to line, draw a line here at this point, vertical 191. Okay, so this is our line of length 191. Now, copy this line forward by a distance of 500. Okay, so copy this line forward by a distance of 500 and create another copy. Copy it forward by a distance of 500. Okay, so we're going to start our drawing with this one. So first and foremost, going back to pipe data, we have, I said, we're going to divide this flange into 3 parts. We have part 1, this side, part 2, this rectangle, and part 3, this rectangle. This side is actually a trapezium. So starting with the outer diameter up here is what? Is 368, while the lower diameter down here is, sorry, the upper diameter here, outer, is 273. The inner is 242.82. While the outer diameter here at this level is actually 368. So I'm going to draw a line, a horizontal line of 368. So I click on line, I draw a line below here of length 368. So next, what do? I select this line and I move it from the midpoint. Make sure your snaps are turned on, your mid-snap point snaps are turned on in object snap, that is all snap settings. So I pick this line from the midpoint and I move it to the bottom of this line I've just drawn. So already I've set my layer. I'm using center layer right now. So having done this line is not supposed to be here. So looking at this point, this is where the line is supposed to be, from this point to this point. So if I move it up by 7, it will land here. If I move it up by 69.9, it's going to land at correct position. So I'm going to move it twice. First by 7. When I move it by 7, it's going to land at this level. When I move it by 69.9, it's going to land at the proper elevation where it's actually supposed to be. So I go back here. So I move this line up by 7. I select it again and I move it up by 69.9. So right now it is actually at the proper position. Okay, it is actually at the what? The proper position. So what next do I do? All I need to do is just to the next thing I'm going to draw is this line at the top here, the outer at the top, which is 273. That is what I'm going to do right now. So I draw another horizontal line of 273. This time around, this line is supposed to be at the top here. So I pick it up. I select the line. I like the line. I go to move. I pick it up from the midpoint and I drop it at the end of this line. So what's the next thing I do? I go to line again. I connect this line and I connect this side to this side. So the next thing, what do I do again? I select 1, 2, 3, 4, 1, 2, 3, 4, the 4 sides of the shape I've just drawn, the trapezium. And I come to my layer. I come to layer. I'm on center line, but I'm going to change it to outer OD. Outer diameter. It's supposed to be on outer diameter. Okay, so let me even keep my layer on outer diameter. So I've drawn the first part. That is this part here. Now it remains the second part. This second part is actually a rectangle. If I stretch this line here, I'm going to have a rectangle. It's actually a rectangle of the length is 545, while the width is 9.9. So I'm going to use rectangle 2 right now. I go to rectangle 2. I click on rectangle. I click anywhere on the screen. On the command line, I click on dimensions. I am told to specify length of rectangle. Length of rectangle is 545. So I type in 545. I press enter. I am asked to specify the width for rectangle on my command line. The width is 69.9. So I type in 69.9. I press enter. And my rectangle is drawn. But it is not at the correct position right now. So let me shift it forward. So now, what do? I select the rectangle. I right click. I go to move. I pick it up from the top midpoint and I drop it here at this level, the center of this line. So I connect it to this line. So I have the second part for my flange. It remains the third one. Okay. So let me go back to pipe data. The third part is still a rectangle of length 323.8, while the width is 7. So I go back to my AutoCAD software. I click on rectangle. I click anywhere on the screen. I click on dimension in the command line. Now I am asked to specify length of rectangle. The length of rectangle now is 323.8. So I type 323.8. I press enter. I am asked to specify width for rectangle. The width is 7. I type in 7. I press enter. And the rectangle is drawn. Now I have to position it at the proper position, proper place. I pick it up. I select it. Rectangle. I right click. I go to move. I pick it up from the top midpoint. And I move it up to connect with this other rectangle at this middle line, the midpoint. So right now, I have my flange. My flange has been drawn. Although there are some details that are not there, but once you draw this, everyone knows this is a flange. This is a raised face flange. This is actually the raised face here. This is the raised face Weld-Neck flange. Okay, so what is remaining in our flange is actually the bolt holes. We've not drawn the bolt holes, so we're going to draw that right now. And the internal diameter has not been drawn. So before we draw the bolt holes, let's draw the internal diameter. What is the internal diameter? The internal diameter is 242.82. 242.82. So then the length of the flange is 191. So I'm going to draw a rectangle of length 242.82 and width 191. So I go back to rectangle. I click anywhere on the screen. I click on dimensions and I draw a rectangle of length 242.82, and the width of my rectangle is actually, what's the width? The width is 191. I type in 191 for width. This is the rectangle, but it's not properly positioned. So I pick it up. I select the rectangle. I right click. I go to move. I pick it up from top midpoint. Then I move. I drop it down here at the midpoint of the upper line of the flange. So right now, let me change the layer to internal. This is supposed to be internal diameter ID. So I change my layer to, I keep that on ID. So right now, this is my flange. This is the ID. This is the internal diameter here. From here to here is the internal diameter. So it remains the bolt holes. That is what is remaining right now. So I am going to draw the bolt holes right now. Now I go back to pipe data. On pipe data, from where I have the bolt holes one bolt holes from the center of the bolt holes on this left hand side to the center of the bolt holes on the right hand side, the distance is 469.9. The distance is what? 469.9. Okay, that is the distance there. So I'm going to do that right now. I'm going to position a center line at this point and at this point as well. Okay, so we go ahead and first and foremost, let me divide 469.9 divided by 0 divided 469.9 divided by 2. I'm going to divide into 2 points, 2 parts, 2 equal parts, so that I can either offset or copy. So 469, let me work out the maths. 2 in 4, 2, 2 in 6, 3, 2 in 9 is 4 remainder 1, 2 in 19 is 9 remainder 1, 2 in 10, 5. So that is 234.95. So half of 469.90 is 234.95. So I come over here. I'm going to offset this line. I'm going to create a copy by 234.95. So I right click, I go to copy. I come here, I copy by 234.95 to the left. So I copy to the right by the same value, 234.95. Okay. So this is the center where the bolt holes are passing. Now, what is the diameter of the bolt? What is the diameter of the bolt? I go back to pipe data. The diameter of the bolt, this is the diameter of the bolt, that's 8.1. Now, what is half of 38.1? Half of 38.1 is 19.05. So I'm going to offset these lines to the left and to the right by 19.05. So I type offset. So I'm asked to specify offset distance. Offset distance is 19.05. I press enter. I'm told to select object to offset. I want to offset this to the left and to the right. I want to offset this to the left and to the right. So right now, I'm going to trim off the excess lines that are protruding, these ones and the one below. So I type in trim, T-R-I-M. I press enter. I press enter again, and I come over here. I sweep over, and I clear the lines here. I click here. I move across, and I click. I click on the right-hand side. Then I move across towards the right. I click again. The same thing over here. I make it larger. I zoom in to make it larger. I click outside, move across the line, and I click again. And the line has been actually been trimmed. Okay. So what do I do? This line wasn't thick, so I'm going to actually let me check. Go back to pipe data. This line was kind of very faint, so I'm going to reduce the thickness of these two lines. I select it. I go to properties, then line type. Line type, looking for line width. Line width by layer. Okay, to 0. So I change it to 0. Okay, it's now lighter. It's lighter compared to what it was before. Okay, but let me actually check. This is line width is off. Let me switch it on. It's now on. Okay, let me increase the line weight of this one, this 2. So, so this is our flange right now. I have our flange. Our flange has been drawn. Okay, I've actually drawn our flange. Normally, I didn't need to put in this internal one because once you draw this shape, one, let me join this together. Once you draw this, once you draw 1, 2, 3, people know it's actually a flange. Okay, so this is our flange with everything drawn. So if you want to draw flange, you don't need to start drawing all this. All you need to draw is just basically except they actually need all the details where you need to put the internal diameter and the bolt holes. This already depicts a flange. So with this, I've actually come to the end of the tutorial for today. I hope you actually enjoyed it. I believe with what I've taught you that you can actually draft, use AutoCAD to draw any flange of any kind, whether it be a Weld-Neck flange, a raised face flange, an RTJ or whatever. You can actually draw your flanges from henceforth without stress, with ease. So in case you need some details for some dimensions, you can feel free to contact me and I'm going to make the dimensions available for you. So thank you so much for joining me today and keep on joining. Your presence is highly welcome. So please, if you're not subscribe to the channel, like the video, drop your comments, click on the bell icon so that you will always be notified whenever I upload a new video. And also, if you have any need to contact me via WhatsApp, you can connect with me on WhatsApp via +234 803829 5185. Then I am available via my social media handles. On Instagram, you can connect with me via Eddysam for real. That is EDDYSAM, the number 4, numerical 4, then REAL. I'm going to put my social media handles in the comment section. So if you haven't need to connect me, in case you need a one-on-one tutorial, I'm available. So I've come to the end of the lesson for today. Bye. We'll meet in the next lesson. Like I said, in the next lesson, we'll actually be creating the 3D model, that is a 3-dimensional model of how the flange actually looks like in real life. So don't fail to join us and be a part of that tutorial. Thank you so much. Bye.